You're listening to Let's Talk Sustainable Business.
Hello, my name is Uwe Schulte, and it's a pleasure to welcome you back to this episode of our series Let's Talk Sustainable Business. It's brought to you by the Conference Board Global Sustainability Center. Today, I'm welcoming back Cyril, the Senior Vice President, Performance Minerals at Imerys. In our last episode, Cyril gave us an overview of the overall sustainability integration into Imerys business and their approach to preserve and restore biodiversity. Welcome back, Cyril.
Thank you, Uwe. I'm pleased to be back with you again. It was an interesting first session, and I'm happy to be able to continue with you today.
Yeah, as you sparked my curiosity last time when you talked about that you are helping your customers to come to a more sustainable solution, and you mentioned, which surprised me a lot, talc into car interiors. Can you give us another example how your minerals can actually do that?
Sure, we have quite a number of good examples. There is one that I like a lot, which is a solution that we call Barricode. Here we are talking about the paper and board industry. I did not mention it last time, but we have also a lot of business in this industry. And here, this solution is about providing what we call barrier properties to paper or board, which means protecting it from water or grease or whatever. So in a nutshell, it's helping to be able to, for instance, put some content into it. The typical example is a coffee cup. Carton board coffee cup, where you want to protect the inside of the coffee cup so that you are able to pour water, coffee inside it by not soaking completely the cardboard. You have solutions on the market to do that, a very efficient solution. And the dominant solution today is to apply a polyethylene film on the carton board so that you have perfect impermeability of the carton board and you can pour your coffee inside the cup. The problem with that solution is that it makes the cup non-recyclable or very difficult to recycle because you cannot really remove easily the layer of polyethylene film. What we have developed is a solution based on water and minerals where we manage to get similar barrier properties, but without this polyethylene, meaning that after use, the cup is fully recyclable. So the solution is working. It's on the market today. And as a matter of fact, we are the supplier of one of the leaders in Europe producing this kind of cups. And in turn, it helps them a lot to propose to the market solution of these coffee cups, which are now recyclable. So that's also one example of ourselves helping our customers.
Now, this is very interesting because I think if we can get away from polyethylene lamination of paper in certain applications, that is very promising. And the way I understand it happens is that whilst the polyethylene is basically like glued onto to the paper, and then when you want to recycle it, you can't easily separate the two. With your mineral, it can be just flushed out by water. Is that what we're talking about?
Yes, basically this is how it works. Yes.
I have to say, I have to be critical on this one, of course. I'd rather have no coffee cups as a single use and people using them differently, like using porcelain cups or stuff like that. But that application of your product is, of course, not limited to coffee cups. So therefore, it's great. Now, I also understand, and that sparked another curiosity. You only mentioned it in a half sentence the last time, is that you are heavily into batteries, for example, for electric vehicles. What have minerals to do with that?
Indeed, and minerals have a lot to do in that. Batteries, as you know, is made of electrodes. You have the anode on one side, the cathode on the other one, and in between you have electrolyte and a separator. And the goal is to make the electrons travel from one side to the other when you charge and discharge the batteries. And here you have a few properties which are very important when you design and operate a battery. And one of them is about conductivity. The more conductive is your battery, the more you facilitate the flow of electrons, the more the performance of your battery can be. And here you can achieve excellent level of conductivity by adding to your battery what we call conductive additives. And the most efficient ones are either graphite or carbon black. And we are leading this market. We are producing and commercializing very high standard products, which are today in a lot of the high performing batteries that you see on the market. This is a really important component on the overall performance of the batteries, and therefore it's helping the transition towards electrical vehicles. And the good thing is that you need these good conductivity properties irrespective of the technology. We are talking about the lithium-ion batteries, but it's also valid for fuel cells, it's also valid for solid-state batteries, and so on. So for us, really the key is to follow the market demand, because as you know, there is a lot of interest for electrical batteries so far. So we are investing a lot into capacity to follow market demand, but also on innovation to always increase the performance of our solutions and help the battery makers to develop even more performing batteries.
Yeah, let's get to the material again, because let's understand this a little bit more. I mean, it's impressive that this is so key to the performance of these components of the electric vehicles. But graphite and carbon black are basically chemically the same. It's just carbon, right? Is that correct?
That's correct.
If I pull out coal from the ground and take the carbon out of that, is that the raw material you're using?
Ultimately, yes, but then you have all the mineralogy, all the shape of the particles, etc., which gives different properties. In our case, we use synthetic graphite, so we produce it ourselves through a process which makes that we control extremely well the final product, and this consistency of the products allows us to have this extremely good performance, and same goes with carbon black.
So graphite, we as normal consumers would know from pencils. Yeah, that's where we get to know graphite. Is that correct?
You get it in pencils. You get it as well in friction materials, like in braking pads, for instance. You get them in refractory materials for the heat conductivity properties. You get it in quite a number of applications, in fact.
Mm-hmm. Okay, so but I just heard you say that you make it synthetically. That means you do this to be able to control the properties better, because there are also graphite mines, I understand.
There is natural graphite as well. You're right, but here we are at such a high level of standard in terms of consistency of the product for the high performance batteries that we get a better performance by producing synthetic graphite, indeed.
Understand. Now, we we are talking about how you are supporting uh, sustainable solution, and electric vehicles is of course a very obvious one. But in essence, the way to look at these things is always, of course, to look at the entirety of the life cycle of such a product. How do your products perform under that scrutiny of a life cycle analysis?
Yes, you're right. It's indeed very important. And for me, there are really two key points here. The first one is, as you say, to take the full cycle. And the second one is to get support from third parties to be as robust as possible in our analysis. Here, through our sustainability programs that I mentioned already, we have defined a strong methodology which is organized in 5 steps. But the main goal is really for us to be able to quantify both, on one side, the impact, and on the other side, the benefits of each of the products, the key products that we are making in their main applications, from the extraction to the end of the life. And this allows us then to rate our products in terms of sustainability. So in practice, we do that by following a framework which is called the World Business Council for Sustainable Development. So we are not inventing our own thing, and we developed a scientifically based, robust, and importantly, fully auditable approach to make sure that we do it in a transparent way, and we base our analysis of input from our own teams, but also from experts, researchers, etc. So we really want to have a view as complete as possible on all these impacts, from mining, manufacturing, but also during the usage phase of our minerals in our customer solutions, as well as the end of life. So based on that, we have defined a pioneer label that we grant to products which in a given application are providing very high social and environmental contribution to the entire value chain. So low environmental impact during production compared to the economic value, and downstream good contribution. And to come back to the example we just mentioned, our synthetic graphite and our carbon black for automotive batteries applications have received this pioneer label, but it's also the case, if I continue with graphite, for instance, for the graphite used in the alkaline batteries and so.
Yeah, this is an impressive process, and I hope that more companies take that approach. But you said an important proviso in here, and I think that is something that we have to bear in mind in a given application, because you can only do this for one of your applications. You mentioned in the last episode how many different customers and applications you have, so each of those applications needs to be looked at separately, of course.
Yes, you're right. And that's the difficulty of it when you have so many products and so many applications as we have. So clearly we are focusing on priorities on the most important products and their most important applications to conduct this analysis. Yes.
No, that's very clear. It can't be done everywhere, but I think that is something that we all have to learn, to set priorities. Sometimes people try to do too many things at the same time. So it's much appreciated. And I think it's also important what you mentioned, that this is externally audited. Very important in this context, I think, because credibility and trust is so important. When you talked about graphite and all of that for electric vehicles, we experiencing now a really very significant growth of these units. Will supply be able to keep up, because we have lots of supply issues these days?
Yes, you're right. It's a big challenge overall. It will be difficult in the coming years. It will be difficult to continue to get all the supplies that everybody would want when we look at all the projects or the new factories for batteries, for electrical batteries. On our side, we try to anticipate by having plans over several years to plan for new production capacities for our carbon black and our graphite. But of course, we are not the only critical component in batteries. We talk a lot about these days, for instance, about lithium, and there will need overall to be a good balance of all these critical resources to make sure that the industry can develop as needed in the future.
Yeah. So I think you give me some sense of optimism here. So that's good. Let's get to another point. It might be a bit fictitious to ask a mining company, and I know you're not a mining company, you are a minerals company, about recycling. But nevertheless, how do you see it going? For example, for batteries?
Recycling is indeed a very important point, and it's a difficulty. We talk or we hear from time to time about urban mining, for instance, which is basically trying to reduce the number of resources that we take from the ground to take them from waste, from products which have been already in operation. In practice, it's often very difficult. In batteries, for instance, separating the graphite and the carbon black is extremely difficult with the current technologies. But there are some other applications where it's more and more possible. And I'm quite optimistic that over the coming years, we will start to see more and more opportunities to use recycled materials. If I can give you one example, we are having a product called Imerys, which is in fact a product for the paper and board industry made from waste from the process of the paper mills. So we are helping them to recycle their own waste to become again a raw material. So that's the kind of things we can do. It's not possible in all applications, but I'm sure that the trend will develop in the future, and we are supporting it, obviously.
Let's just get back to urban mining that you mentioned. Surely for these batteries, we don't need urban mining, because my understanding is that urban mining would mean it goes on to waste disposal landfill or something like that, and we pull it out again. But for batteries and stuff like that, we can have a full loop. Correct, or was I misunderstanding something there?
You can have several lives to a battery. Typically, what happens is that you start with the first usage of the battery in electrical vehicles, because this is where you need power, where you need longevity, etc. But then over time, the battery performance is decreasing, and a typical second usage for these batteries is to use them in what we call energy storage solutions. So typically the batteries that you can use in your homes to store solar energy, etc. And that's the kind of recycling solution, if we may say, or reuse solutions for the batteries. And indeed, when I refer to urban mining, was more to break down used products in order to recover the raw materials which contributed to make them in the first place.
No, then I understand. You see, urban mining for me is sort of that you go to one of these big dumps, and you dig up the dumped stuff there. So, but what you're talking of, after reuse, actually breaking the battery into parts, and that has still some challenges. But I understand there are now large-scale facilities being built as we speak. For example, in Norway, I'm
Indeed,
not familiar
yes.
with the.
Yeah.
Well, okay. Yeah, we touched the last time a little bit on greenhouse gas, and of course, whilst we focused in the first episode very much on biodiversity, and I think this is a very, very important part, and it was very gratifying to hear that you're collaborating with others on that one. Still, carbon footprint is something that is important. How do you approach that in your operations?
Yes, we consider as well that it's a very important topic. The good thing is that there are lots of things we can do about it. However, it takes time and effort. And for me, the key is first to be aware about it, and second, to have plans over several years in order to launch the right action. So for ourselves, we have set up strong target, ambitious target to reduce our emissions of CO2 over time, and we are working on a number of different options. All in parallel, I should say. The first one is obviously to use more renewable energy, but the second important one is to recover energy from our processes. Very often we generate some heat that we can then recover to reuse later on. We can improve our process efficiency to consume less energy in the first place. We can also, I mentioned that last time, but engage our suppliers themselves to have science-based targets to reduce their own carbon footprint. And last but not least, we are now systematically including an assessment of the CO2 emissions in our key business decisions, important investment project, acquisitions of other companies, etc. We look at the CO2 footprint impact on the group as part of the decision process.
I don't want to spy into your business decisions, but this is very encouraging, and I would love to understand a little bit better. This means that you make an assumption on the price of carbon, and you introduce that into your capex decision. Is that what you're saying?
Indeed, we consider we put a price per ton of CO2 that is impacting the financial return positively or negatively depending on the project, and at the same time we also look at the mix of energies in the country where we operate. We know very well that depending on the country where you operate, the energy can be more or less carbon intensive. So we take that into account together with the opportunity or possibilities to improve the situation over time. Our main focus is to be able to make progress in that respect. So for instance, if we have a project which has a good perspectives of being improved thanks to future biomass project, for instance, then it's something that we see very positively.
Okay, that is also a very important point, that you make certain assumptions of technology becoming available for you. That I think in these fast-moving times is an important step.
Yes, it's an important one, and to be clear, we are, I would say, more starting on that one. So we are looking at the options available. We are progressively including that in our decision process, but we still have some way to go.
No, of course, but we have to all get started on these things, and it is important. And on the other hand, a very difficult one to judge, of course, because the price of carbon might even vary from region to region over a longer period of time. So that's, but hopefully that gets everybody into the right direction. You sparked another question in my mind. You talked about engaging suppliers and encourage them to go for SBTI. Sorry, I'm using acronyms now. Science-based targets, the initiative that tries to have sector-specific targets for companies to reduce the carbon footprint of the operation to below to achieve the 1.5 science target. What's your experience there? Because when we talk to other companies, a lot of suppliers, especially smaller scale suppliers, haven't got visibility of their carbon footprint yet.
Yes, that's exactly the main difficulty that we are facing as well. We have some success, but it takes time and effort. For large suppliers, multinational ones, etc., it's a discussion that is fairly easy to have because they understand, and even if some of them are sometimes a bit late, this is the direction to which they want to go. For smaller ones, especially in some countries, it's something much more difficult to achieve. So we are not targeting 100% of our suppliers being part of that, but we are definitely pushing to get more and more of them involved, betting on the fact that the more we do it, the more it will have a positive impact on the overall chain, and that in turn it will also push them to request the same from their own suppliers.
Excellent. Thank you for clarifying that. Yeah, unfortunately, we're running out of time again. This was extremely interesting. In the first episode, I saw how you personally learn from bad examples of how not to do quarrying from your journeys around the world. How your company Imerys is trying to have a restorative approach to biodiversity, and today we spent some time on understanding a bit more about these fascinating minerals you're dealing with, and it's from toothpaste to talc in cars to carbon in batteries. Fascinating. Thank you for sharing that with us and giving us some background on sustainability aspects of mining.
You're welcome. It was a pleasure to share this time with you. I hope I could convince you that minerals have really an important role to play in contributing to the solutions of tomorrow. And as a matter of fact, this is what we are continuously trying to do in Imerys, and to find ways to operate more efficiently, to reduce our impact for ourselves, but also with our partners, customers, and suppliers.
Yeah, thank you so much, and I wish you continued success with that. And for our audience, if you've enjoyed this episode, please remember to subscribe to our podcast series or explore the entire catalog of podcast programming from the conference board by visiting the website at tcb.org/podcasts. You can also write to us at sustainability@tcb.org. For today, I would like to thank you for listening, and please join us again the next time. Goodbye.
That was Let's Talk Sustainable Business.